Hello friends, welcome to Aravalli Geo Academy. Today we are going to discuss the next part of the chapter 1, Earth and its atmosphere. So we have already covered the troposphere, the stratosphere, mesosphere, or in this video we will discuss the thermosphere, ionosphere and exosphere. So first we will discuss the thermosphere. Thermosphere, it means this is a hot layer just above the mesosphere. Okay, this is the next layer just above the mesosphere is known as thermosphere. Therm, it means temperature. So temperature is higher in this layer. So this layer is the hot layer. And mesopods separate the mesosphere from the thermosphere. This mesopause is boundary between the mesosphere and thermosphere. We already know tropopods separate the troposphere to stratosphere, and stratopods separate stratosphere to mesosphere. And this mesopause separate the mesosphere from the thermosphere. In the thermosphere, oxygen molecules absorb energetic solar rays. The absorption warm the air in the thermosphere. Okay, so in the thermosphere, oxygen molecules absorb the energetic solar ray, and due to this absorption, temperature is higher in the thermosphere. Next, due to the low molecular density, even the small energy absorption cause a large temperature rise. Okay, this is the conceptual point. Uh, Low molecular density. Why the molecular density is low in the thermosphere? Because volume is higher, or in the particular volume, only few air molecules is there. Okay, so molecular density is the low in the thermosphere. Okay, or due to this low molecular density, the small energy absorption cause the large temperature rise, because fewer molecules actually distribute more energy, so temperature is the higher here. And in the thermosphere is where the solar charged particle interact with air to create aurora. This point is very important. Aurora present in which layer of atmosphere? Thermosphere. Okay, and is this aurora will form due to the solar charged particle interact with air, then this aurora is formed. Okay, so in upcoming videos we will discuss the type of aurora. There are two type of aurora we will discuss: aurora borealis in the northern hemisphere, or aurora australis in southern hemisphere. But you remember, aurora is actually present in which atmospheric layer? So your answer will be thermosphere. Okay, now we discuss the exosphere. Okay, so exosphere is the last layer of our atmosphere on the basis of temperature. So around the 500 kilometer above earth, some light fast molecule escape into the space. Okay, and this escape zone is known as exosphere. So exosphere is the outermost layer of the earth atmosphere. This just actually beyond the thermosphere. And this exosphere marks the outer boundary of the atmosphere. Examiner directly asks you which layer is the outermost layer of our atmosphere. So your answer will be exosphere, and the exosphere marks the upper boundary of the atmosphere. Atmosphere also can divided on the basis of composition like this. See this picture. So this is very important for the CSIR-NET. Listen very carefully. So we classify the atmosphere on the basis of temperature, and on the basis of composition, on the basis of electric properties. So there are three lines: red lines, green line, and blue lines is there. So actually red lines indicate the temperature, and green line indicate the composition, and blue line indicate the ionic property or electric property. So on the basis of temperature, we can classify atmosphere into 5 layers. The bottommost layer is the troposphere, stratosphere, then mesosphere, then thermosphere, then exosphere. So on the basis of temperature, there are 5 layers. Okay, and on the basis of composition, there are 2 layers: homosphere and heterosphere. Up to 85 kilometer, this is the homosphere. It means composition is actually constant in the homosphere, or in heterosphere composition is the change, or this ionosphere is not a separate layer. Okay, actually ionosphere is the combination of mesosphere and thermosphere, and maximum part of this ionosphere lie in the thermosphere. Okay, so let's we discuss one by one. So below the thermosphere, air composition stay uniform. Okay, due to this turbulent mixing, so this zone is known as homosphere. Okay, this is homosphere due to the turbulent mixing. But the composition of this homosphere is 78% is nitrogen and 21% is the oxygen. Okay, so composition of the homosphere is the same. Now next, the thermosphere is fewer collision prevent effective mixing. In homosphere, the turbulent mixing is there, but in heterosphere or thermosphere, only fewer air molecules is there. So the fewer molecules is there. So for the collision, the air molecules travel the long distance. So due to this long distance, the mixing is less as compared to homosphere. And due to this mixing, uh, the composition of atmosphere is different. Okay, so the layer of the thermosphere base to the top of the atmosphere is called heterosphere. Okay, because composition is different. Now we discuss the ionosphere. The ionosphere is an electrified region. This is not a distinct atmospheric layer because this is a combination of mesosphere and thermosphere, and it exists within the upper atmosphere. Okay, it's contain high concentration of ions and the free electrons. Okay, and ions are atom or molecule that have lost or gained electron regularly. The lower atmosphere start around the 60 kilometer, and upper actually top part is not defined, but top part maximum lie in the thermosphere. Okay, so it extend upward to the top of the atmosphere. The most of ionosphere lie within the thermosphere. This point is very important. The ionosphere lets the TV and FM radio wave pass through. Okay, so TV and FM radio wave pass through the ionosphere, and at the night the ionosphere reflect AM radio wave back to the earth, and this reflection allow AM wave to travel long distance. Okay, this point I will explain through the picture. See this picture. Okay, so this is the sun and this is the moon. Okay, sun indicates this is the daytime and this is the night time. Okay, so this is the classification of the ionosphere. So ionosphere classify on the basis of the property D layer, E layer and F layer. D is the bottommost layer of the ionosphere, and E layer just intermediate, then F layer. Okay, so focus here in the night time, this D layer is absent. Okay, so in the daytime, the AM radio wave travel the actually less distance as compared to night time. In night time, this D layer is absent or disappear. So AM radio wave travel the long distance. Okay, before the reflection. So remember this point also. So this is all about the thermosphere, ionosphere and exosphere. In the next video, we will cover the atmosphere of the other planets. So if you have any doubt, then drop a message in the comment section. So thank you so much for watching this video. Try to share this video with your friends, those preparing for the CSIR-NET. Okay, so thank you.